For as long as humanity has looked up at the night sky, we've wondered, are we alone? Is there life beyond Earth, scattered across the vastness of the cosmos? Or is our planet the only cradle of life in this immeasurable universe? These questions have sparked our deepest curiosities and inspired our most profound dreams. Dreams of exploring the unknown, reaching beyond the confines of our world, and finding out if the miracle of life is unique to Earth, or if it exists in other corners of the cosmos. As the centuries have passed, our ability to answer this question has evolved from myths and legends to scientific hypotheses and now to active exploration. We are at the threshold of a new chapter in humanity's quest to understand life, not only as it exists on Earth, but as it may exist in the boundless reaches of space. In many ways, we've already begun our search. Scientists, equipped with the latest technology and bold ideas, have already begun to probe the universe for signs of life, looking not only for planets and moons that might harbor life, but also for the very conditions that might allow life to flourish. The tools at our disposal are more advanced than ever before, enabling us to explore distant worlds with an accuracy and precision that was once unimaginable. We are not just stargazing. We are actively searching, testing, and discovering in ways that will redefine our understanding of life itself. One of the most promising advancements in the search for extraterrestrial life is the James Webb Space Telescope, our most powerful tool yet in the quest to understand the cosmos. Webb's unprecedented ability to peer into the infrared spectrum allows it to detect and study exoplanets, planets orbiting stars far beyond our own solar system. These planets, some of which are located in what is known as the habitable zone, are areas where liquid water could exist, an essential ingredient for life as we know it. But it's not just about finding planets in the right location. Webb's instruments will allow us to analyze the atmospheres of these distant worlds, searching for chemical signatures, biosignatures, that could indicate the presence of life. These signatures might include gases like oxygen, methane, or carbon dioxide, which are often produced by living organisms on Earth. With Webb, we are about to unlock the first detailed glimpses of planets that may harbor life, revealing whether conditions on these distant worlds are suitable for life to exist. But the search for life isn't just confined to distant exoplanets. Right here in our own solar system, we find worlds with environments once thought to be inhospitable, yet now reveal the possibility of life thriving in the most extreme conditions. Take Mars, for example. Once a world of flowing rivers and vast oceans, Mars now appears cold and barren. Yet, beneath its arid surface, there are signs of ancient lakes, dried-up riverbeds, and minerals that could only have formed in the presence of water. The Perseverance rover, which currently explores the Martian surface, is searching for signs of past life, digging into the planet's soil and rocks, collecting samples that will one day be returned to Earth. If life ever existed on Mars, these samples could contain the key to understanding how life began on our planet, and perhaps how life might begin elsewhere. Mars is not the only target. Jupiter's moon Europa is another intriguing world. Beneath its frozen crust, scientists believe lies a vast ocean, an ocean that could harbor the ingredients for life. Tidal forces from Jupiter's immense gravity keep Europa's ocean warm, and organic molecules, which are the building blocks of life, have already been detected on the moon's surface. The upcoming Europa Clipper mission will examine this enigmatic moon in greater detail, searching for signs that life may exist in this hidden, icy world. And then there's Saturn's moon Enceladus, which has fascinated scientists for years. In 2005, NASA's Cassini spacecraft discovered plumes of water vapor erupting from cracks in Enceladus's icy surface, plumes that contain organic molecules, another key ingredient for life. Could these plumes point to a subsurface ocean that might harbor microbial life? Future missions could help answer this question, bringing us closer to understanding whether life exists in the watery depths beneath Enceladus's frozen exterior. These moons, and others like them, are not just barren ice worlds. They are living laboratories, offering clues about how life could emerge and survive in extreme environments. The study of these celestial bodies is not only reshaping our understanding of astrobiology, but it's also pushing the boundaries of what we thought possible. The more we explore, the more we realize that life might not need Earth-like conditions to take root. Life could exist in places far beyond the comfortable, temperate environments we once thought necessary. On planets orbiting distant stars, in the icy depths of moons, or even in environments that challenge our most basic assumptions about what life needs to survive. On Earth, we find life in places we once thought impossible. At the bottom of the ocean, in boiling hot springs, and in the frozen deserts of Antarctica. These extremophiles, organisms that thrive in extreme conditions, are reshaping our understanding of life's resilience and adaptability. Their existence suggests that life might not need oxygen, sunlight, or even liquid water in the way we typically imagine. Instead, life could be based on entirely different principles, thriving in places far harsher than anything we experience on Earth. By studying Earth's extremophiles, we can better understand what to look for when we search for life elsewhere, especially in environments that seem hostile or alien. In fact, extremophiles are teaching us that life could take forms far different from what we recognize, existing in conditions once deemed uninhabitable. This opens the door to a universe full of possibilities, where life may exist in forms and environments we have yet to imagine. While we search for life within our own solar system, we are also looking outward, into the distant stars. Some of the most fascinating exoplanets orbit red dwarf stars, stars that are much smaller and cooler than our Sun, yet they are the most common stars in the galaxy. These planets are often found in the habitable zone of their stars, where conditions could allow liquid water to exist. As new telescopes and observatories like the James Webb Space Telescope and the Extremely Large Telescope come online, we will be able to study these planets in greater detail than ever before. Are they barren rocks, or could they harbor the key ingredients for life? Astrobiologists are already looking for signs of life on exoplanets by studying the chemical composition of their atmospheres. Oxygen, methane, and other gases that are commonly associated with life on Earth are being monitored by telescopes, and future missions will continue to analyze these distant worlds for signs of biological activity. The search for extraterrestrial life is not just a scientific endeavor, it is a deeply philosophical one. If we find life, even in its most basic form, it will force us to reconsider our place in the universe. It will raise profound questions. What does it mean to be human? What is the nature of life itself? Are we part of a greater cosmic community, connected to life across the stars? And what about intelligent life? For decades, scientists have listened for signals from extraterrestrial civilizations, scanning the skies for radio waves or other signs of communication. Though we've yet to hear anything, the search continues. The very idea that we might one day detect a signal from another intelligent species challenges our assumptions about life, technology, and our future in the cosmos.